I'm pretty sure this is the video that you guys have been waiting for quite a long time. And time has finally come where we'll be working on the iris data. And when I say working on iris data set, you would be training. First of all, you'd be creating your model. You'd be training your model. And then we will try and get some predictions out. So does it not sound all interesting to you guys? So whatever we understood or whatever we learned theoretically, now we are going to apply those techniques practically, right? So let's get on with it. So what we have to do is we just simply take, as a first step, what we are doing is we are splitting the data into X and Y. So remember, I told you that you have the X-axis and you have the Y-axis, right? So here we are saying that in X-axis, I want all the features. And when you say drop, I'm saying don't take the data which is related to ID or species, because remember, this was our labeled data set, right? So species is actually our output. So here, that's why the X-axis, we will have all the features. So and Y-axis will have the features itself, the species itself, right? So let's take X and Y. So let's go back to our model or Jupyter Notebook, and we say X is drop columns, right? So we are saying drop the columns ID species. So we are dropping this column completely ID, and we are dropping species. So what are we left with? We are left with sepals length, sepal width, petal length, petal width, right? This goes on our X-axis, right? And Y-axis has the actual species. So it's the same concept of dependent variable and independent variable, right? So species is you can say the dependent variable, and all these are kind of independent variables, right? Perfect. Now we actually go and say print. So let's say you would obviously want to see what is in my X and what is in my Y. So I go back, I say print X.head, Y.head, right? And what do we get? So for X.head, so let's actually do it one by one. It would be better. So print X.head. So what do you get in print X.head, right? So you are getting, as I told you, all the remaining data, right? Except the ID and species. So you're getting the sepal length, sepal width, petal length, petal width, right? Same way, if you do print Y.head, as I said, Y is your species. So if you do this, you will get all your species like Aristatosa, Virginica, right? What all species you have, that you get. Okay, perfect. Now what we need to do is we need to go back and we have to create our own machine learning model. Yeah, it's pretty simple. We are using just simple Python. So what we will do is we will create a machine learning model and we'll initialize the model with default settings. So the concept is you use sklearn.linear model, and remember, we are using regression here. So you learned about the regression technique. Here we are actually utilizing the regression practically, right? And you're using a variable ML machine learning underscore model and logistic regression, right? So just simply copy, take it over there, and simply run the code. And I will always recommend that you just simply do the way I'm doing. Just simply copy one at a time, right? One step at a time. Now we will actually train our model, okay? So as I said, training data is always different from testing data. So you're training the model on the features X. What are the features X? The features X are sepal length, sepal width, petal length, petal width, with corresponding labels Y, right? Now you're telling your, say, algorithm that, hey, look at this data set. So I'm training you on this data set, correct? So let's train our model. I say, so this is, I'm using logistic regression. Okay, all good. Now, what did we study? We said you have to look at the patterns, and then the model needs to give you the predictions, right? So let's first test the prediction using a trained model. Let's say now our model is trained, right? And our model name is ML. So ML underscore model, right? That is our model. And now I'm using another variable which is ML underscore predictions. So And now I'm here using a test data, right? As I told you, test data is always different from the trained data. And just think what I'm giving. So I'm giving us a specific value. I'm telling the computer that, hey, I've got this new data set which has got this sepal length, this sepal width, this petal length, and this petal width. Now, based on your intelligence, can you now tell me that which category of iris flower does this belong to? So the computer needs to just look at this data set, right? And now it has to give me the output, whether it is iris setosa, it is veriscular, virginica, what type of flower is it, right? So we run this, right? And then we simply print it, right? Now we will print the predictions. As simple as that. So nothing difficult, right? So now we are saying, can you now print the prediction that you did? Perfect. See, that's the beauty of machine learning. I just gave it the features. Just based on the features, it was able to tell me that whether this thing or this picture is a cat or a dog. In this case, I'm telling, based on these features, it was so intelligent. My model is so intelligent now that it can accurately tell me that which category of iris does this belong to. And it gave me, yes, this test data should be related to iris setosa. So I guess this was a perfect, simple example of machine learning and how you can use machine learning practically. Thanks for watching.